In this video, we're going to learn how to solve equations that have algebraic fractions in them. This video is going to build upon a previous video, the one titled Algebraic Fractions Operations. I'll put a link in this video's description just in case you want to check that one out first. So let's take an equation that has some algebraic fractions in it. What we're going to do is focus on the left hand side first of all and try and combine these into one fraction. To do this, we need to make sure we have a common denominator. At the moment, the denominators are 6 and 4. The lowest common multiple of these is 12. So we could rewrite the left hand side as two fractions that are both over 12. If we compare these two fractions here, to get from 6 to 12 on the bottom, we must have multiplied by 2. So we need to multiply the top by 2. So that's 2 lots of x plus 3. For the second fraction, on the bottom to get from 4 to 12, we've multiplied by 3. So we multiply by 3 on the top. 3 lots of x plus 1. And the right hand side is still equal to 3. Now that we have the common denominator, we can combine these into one big fraction all over 12. So we've got 2 lots of x plus 3. In between them we have a plus sign, and then 3 lots of x plus 1, and the right hand side is still equals 3. Next we need to expand the brackets. So I'm going to write the over 12 and the equals 3, and then we're going to expand the numerator here. So we've got 2 lots of x, that's 2x. 2 lots of positive 3, that's positive 6. Then we've got a positive 3 times x, that's positive 3x. And then positive 3 times positive 1, that's positive 3. We can now tidy up that numerator a bit by collecting like terms. So if we write the over 12 and equals 3, we've got 2x and 3x, that adds to make 5x, and then we've also got a 6 and a plus 3, which gives you 9. We've now turned this into a relatively straightforward equation to solve. We can multiply both sides by 12 to get rid of that fraction. If you multiply by 12 on the left, you get 5x plus 9. And if we multiply by 12 on the right, 3 times 12 is 36. Then just subtract 9 from both sides. This will give you 5x equals 27. And then divide both sides by 5. And this gives you x equals 27 divided by 5, which is 5.4. So the solution to this equation is 5.4. Now let's try another example that's a bit more tricky. So for this one, we're going to use the same approach at first. We're going to leave the right hand side alone and try and combine the left hand side into one big fraction. Looking at my denominators this time of 6 and 9, the lowest common multiple is 18. So I'm going to write both of these as something over 18. For the first fraction, to get from 6 to 18, we multiply by 3. So we need to multiply x plus 2 on the top by 3 as well. So 3 lots of x plus 2. For the second fraction, to get from 9 to 18, we multiply by 2. So we need 2 lots of the top, so 2 lots of x minus 1. And keep that right hand side the same, equals 2/3. Now we have that common denominator, we can combine them into one big fraction all over 18. So we have 3 lots of x plus 2, then in between them a subtraction sign, and then 2 lots of x minus 1. And keep that right hand side the same, that's 2/3. Then as we did before, we're going to expand those brackets. So we'll write the over 18 and the 2/3 down, and then expand these brackets. We've got 3 lots of x, that's 3x. 3 lots of positive 2, that's plus 6. Then we have negative 2 times x, that's negative 2x. And you have to be really careful on this one, this is a really common mistake. Negative 2 times negative 1 is positive 2. Then as before, we'll collect the like terms on the numerator, so everything else can be written down as the same. And then on the top, we've got 3x minus 2x, that's just 1x. And then we've got 6 plus 2, which is 8. The next thing I would do here is multiply both sides by 18. If we multiply by 18 on the left, that will cancel the 18 that's there, so we just have x plus 8. And if you multiply the right hand side by 18, we've got 2/3 multiplied by 18. That's just the same as 2/3 of 18. 2/3 of 18 is 12. Finally, if we subtract 8 from both sides, we end up with the answer x equals 4. Now let's increase the difficulty once more and have a look at this question here. When we look at the denominators of these fractions, we can see they both have two terms. This means to find their lowest common multiple, we're going to need to multiply them together. So both of these fractions can be rewritten as something over x plus 2, x plus 5. Let's look at the left fraction first, so this one. To get from x plus 2 to x plus 2 multiplied by x plus 5, we obviously multiply by x plus 5. So we need to do this on the top as well, so we need 4 lots of x plus 5. And then we can look at the second fraction. So to get from x plus 5 to x plus 2 multiplied by x plus 5, we multiply by x plus 2. So on the top, we need to multiply by x plus 2 as well, and that's 4 lots of x plus 2. And of course, the right hand side is still just 2. Now that we have this common denominator, we can write them as one big fraction all over x plus 2, x plus 5. So on the numerators, we have 4 lots of x plus 5. Then in between them, we have a plus sign, and then 4 lots of x plus 2. And the right hand side is still equals 2. We can now do some expanding and then simplifying. So if we expand out the numerator, we've got 4 times x, which is 4x, 4 times 5, which is plus 20, 4 times x, which is 4x again, and then 4 times 2, that's a positive 8. Next, we need to do the simplifying of the numerator. So on the top here, we have 4x plus 4x, which is 8x. And then we also have 20 plus 8, which is 28. Next, we're going to multiply both sides of this equation by both of those brackets that are on that denominator. So by x plus 2 and x plus 5. This will clear the fraction on the left hand side to give us 8x plus 28. But on the right hand side, we'll have 2 lots of x plus 2, x plus 5. Next, we'll leave the left hand side alone. And then we've got 2 lots. And then we'll expand those brackets, and whatever we get will go inside this much larger bracket here. So if we expanded that double bracket, we'd have x times x, that's x squared. We then have x times 5, which is 5x, and 2 times x, which is 2x, and 5x and 2x adds to make 7x. And then finally, we'd have 2 times 5, which is 10. On the right hand side, we can then expand this bracket. So if we leave the left hand side alone, on the right hand side, we have 2 lots of everything that's in that bracket. So 2 lots of x squared, 2 lots of 7x, that's 14x, 2 lots of 10, that's 20. You can now see we have a quadratic equation to solve. When we solve these, we need to set one of the sides equal to 0. Since the 2x squared is on the right hand side, I'm going to make the left hand side equal to 0. To do this, I need to take away 8x and also take away 28 from both sides. If I took away those from the left hand side, I'd get 0. And if I take those away from the right hand side, the 2x squared will remain unchanged. But then I need to take the 8x away from the 14x, which is 6x. And then take the 28 away from the 20, which is -8. Now there's a common factor of 2 here to all terms, so I can divide both sides by 2. If I divide the left hand side by 2, 0 divided by 2 is still 0. But then on the right hand side, 2x squared divided by 2 is 1x squared. 6x divided by 2 is 3x. And -8 divided by 2 is -4. Fortunately for us, this quadratic will factorise. So on the left hand side we have 0, and the right hand side will factorise to give x plus 4, x minus 1. This leads us to two solutions. Either the first bracket is 0, so x plus 4 equals 0, in which case x is -4, or the second bracket equals 0, so x minus 1 equals 0, gives us the solution x equals +1. Now let's have a look at an even trickier question. So for this one we need to solve an equation, but we've told we need to give the answer in a particular form. A plus or minus square root 13 over b. This is a clear indication that when we get to a quadratic at the end, it's not going to factorise anymore. We either need to use the quadratic formula or complete the square to get the solutions. So let's go ahead and try and solve this one. So first of all, we'll look at those denominators and we can see we've got x plus 3, x minus 3, so the product of those will become our denominators. Then we compare the first fractions, so to get from x plus 3 to x plus 3, x minus 3, we multiply by x minus 3. So we need to multiply that 6 on the top by x minus 3. And when we compare the second fractions, this time we've multiplied by x plus 3, so on the top we need 2 lots of x plus 3. And this equals 3. Now we can combine them into one big fraction over that common denominator. We have 6 lots of x minus 3. In between the fractions is a subtraction sign, and then 2 lots of x plus 3. Now we can expand out those brackets, so on the top we've got 6 times x, that's 6x. 6 times -3, -18. -2 times x, -2x. And a -2 multiplied by a +3, that's a -6. Then we can collect those like terms. So on the top we've got 6x, take 2x, that's 4x. And then -18 subtract 6, that's -24. Then we would multiply both sides by that denominator x plus 3, x minus 3. This will clear the fraction on the left hand side, so you've just got 4x minus 24. But on the right hand side we have 3 lots of x plus 3, x minus 3. To solve this we'll leave the left hand side alone. And on the right hand side we've got 3 lots of whatever we get when we expand these two brackets. Well, this one's the difference of two squares. If we do x times x we get x squared, and then we have x times -3, -3x, but also +3 times x, which is +3x, so those x terms will cancel, and then we have 3 times -3, which is -9. So we have 4x minus 24, and then if we expand this bracket, 3 lots of x squared is 3x squared, and 3 lots of -9 is -27. So you can see we do have a quadratic and we need to get one of the sides to be equal to 0. Once again, I'm going to make that the left hand side. So to make the left hand side equal to 0, I would need to subtract 4x and then add 24 to both sides. So if I do that on the left, I get 0 of course. And on the right hand side I get 3x squared, that remains unchanged. Then I subtracted 4x, and there's no x term there already, so that's just -4x. And then we need to add 24 to -27, which gives us -3. So we end up with this quadratic equation here to solve. Now remember, we know from the form they want the answer in, We need to solve this using the formula or completing the square, and this one's probably going to be much easier using the quadratic formula. So we need to find the values of a, b and c. They're the coefficients of x squared, x and the constant term. So the coefficient of x squared is 3, the coefficient of x is -4, and the constant term at the end is -3. So a is 3, b is -4, and c is -3. Now we can substitute those values into the quadratic formula. It's x equals -b. Well, b is already negative, so if we did -b, it would become positive. So it's actually a +4 plus or minus the square root of, then b squared, so -4 squared, subtract 4 lots of a, which is 3, multiplied by c, which is -3, and all of this is divided by 2 lots of a, and 2 lots of a is 2 lots of 3, so 6. Now this question would actually be a non-calculator question, so we're going to need to work out the value of the number that's inside that square root. So let's write x equals 4 plus or minus the square root of over 6, but we'll work out what's inside that square root. So if we did -4 squared, that would be -4 multiplied by itself, so 16. And then if we did -4 multiplied by 3, that's -12. And then multiply that by -3, that becomes a +36. So we end up with 16 plus 36 inside that square root. You can add those two together, that's 52. So x equals 4 plus or minus square root 52 over 6. Next, what we need to do is simplify that square root 52. So using our surd rules, if we take root 52, that could be expressed as root 4 multiplied by root 13. The square root of 4 is just 2, so this is 2 root 13. So in place of root 52, we could write 2 root 13. So it's x equals 4 plus or minus 2 root 13 now over 6. Now this is looking a lot like the answer, but we're still not quite there. That one just has one square root 13 and we have 2. The reason for that is we have a common factor of 2 here. If we divide all terms by 2, we get x equals. If we divide the 4 by 2, we get 2. Divide 2 root 13 by 2, you get 1 root 13. And divide 6 by 2, you get 3. This answer now matches the form we were asked in the question. You can see the value of a is 2 and the value of b is 3. Now we're going to look at one more final question. This one here. We're going to start this one how we started all of the previous questions. We're going to write the left-hand side over a common denominator. So for this one, it'll be the product of x plus 17 and 2x minus 5. So if we compare these first two fractions, you can see we've multiplied by 2x minus 5. So if we multiply by 2x minus 5 on the top, we get 3x lots of 2x minus 5. And for the right fractions, when we compare these, we've multiplied by x plus 17, so we need 3 lots of x plus 17. And the right hand side is equal to 3 over 4. Now we have that common denominator, we can write them as one big fraction. So we've got 3x, and then brackets 2x minus 5. Then we have a subtraction in between them, and 3x plus 17. Next, we're going to expand out that numerator, so we'll write everything else the same. We have 3x multiplied by 2x, that's 6x squared. 3x times -5, that's -15x. -3 times x, -3x. And -3 multiplied by a +17 is -51. Now there's a little bit of simplifying we can do on the numerator. So we can't simplify the 6x squared, that's the only term with x squared, but we can simplify negative 15x, subtract 3x, which is negative 18x, and then subtract 51. So now we've written the left-hand side as a single fraction. What we're going to do next is multiply both sides by both of those brackets on that denominator. So if we multiply the left-hand side by x plus 17 and 2x minus 5, that will clear the fraction. So we've got 6x squared minus 18x minus 51. And on the right-hand side, we've just multiplied this 3/4 by both of those brackets. Now in the previous couple of questions, we haven't had to deal with a fraction like this on the right-hand side. It was just an integer before those two brackets. To deal with this fraction, you can just multiply both sides by 4. If we multiply the left-hand side by 4, we get 4 lots of the left-hand side. And if we multiply the right-hand side by 4, that 4 will cancel, so we've just got 3 lots of those two brackets. Now we've got lots of expanding to do. So on the left-hand side, we need to multiply by 4. So we've got 4 lots of 6x squared, that's 24x squared. 4 lots of negative 18x, that's negative 72x. And 4 lots of negative 51 is negative 204. Then on the right hand side, we're going to write a 3 and then a big bracket. Then expand out the double bracket and write the terms inside this big bracket. So we've got x times 2x first, that's 2x squared. Then we would do x times negative 5, so negative 5x. But we would also do 17 times 2x, which is a positive 34x. So we've got negative 5x plus 34x. That's positive 29x. And finally, 17 multiplied by negative 5 is negative 85. We can leave that left-hand side alone and expand this bracket on the right-hand side. We need to multiply by 3 this time. 3 lots of 2x squared is 6x squared. 3 lots of 29x is 87x. And 3 lots of negative 85 is negative 255. So we do end up with a quadratic equation to solve. Since we have more x squareds on the left-hand side, I'm going to make the right-hand side equal to 0 on this one. So I'd need to subtract 6x squared, subtract 87x, and add 255 to both sides. So on the left-hand side, if I subtract 6x squared from 24x squared, I get 18x squared. And then if I subtract 87x from the 72x, we get negative 159x. And then if we add 255 to negative 204, we end up with a positive 51. And the right-hand side we know will equal 0. Now let's take that quadratic equation and we're going to solve it. This one does look really nasty because of the size of the numbers, but there is actually a common factor of 3 here. If you divide 18x squared by 3, you get 6x squared. Divide negative 159x by 3, that's negative 53x. And divide the 51 by 3, that's 17. And of course, if you divide 0 by 3, that's still 0. So we're going to factorize this one actually. It will factorize into 2 brackets. Now it's actually quite fortunate we have a 17 at the end. Since we have a 17, that's a prime number, we know its factors are only 1 and 17. So if it did factorize, the only possible numbers we could put at the end of these brackets would be 1 and 17. And they would actually both be negative as well. Since a negative times a negative gives you a positive, so we still get a positive 17, but the only way we'd end up with a negative 53x is if we had negative terms here. If they were both positive, that 53x wouldn't be attainable. So we can put negative 17 and negative 1 in these brackets, And then we just need to think about a few of the different combinations to try and get that 6x squared. So we're either going to use a 6x and a 1x, or a 3x and a 2x. Now if you try a few different combinations out, it shouldn't take you too long to realise we need 2x minus 17 and 3x minus 1. If you want, give this a go and expand it out and you'll see it does give that quadratic above. So finally, to get our two solutions, we need to set the first bracket equal to 0, so 2x minus 17 equals 0, or the second bracket equal to 0, so 3x minus 1 equals 0. To solve the left one, you can add 17 to both sides and get 2x equals 17, and then divide both sides by 2 to get x equals 8.5. For the right one, you can add 1 to both sides, so 3x equals 1, and divide both sides by 3 to get x equals 1/3.